Welcome to this video about solving quadratics using the square root method. So let's do some review about our factoring. So we have two terms equal to 0. The equal to 0 is a clue that you're wanting to solve, meaning find where the graph crosses the x-axis. When you have two terms, one of the things you've got to think about, first, check for GCF. Second, is this a difference of squares? Okay, so when I look, there is no GCF between these two terms, but I do notice that this is a difference of squares because x squared is a perfect squared. It's found by taking x times x, and 25 is a perfect square. It's 5 times 5. And there is subtraction between them. So remember, we talked about the pattern that is made. When we factor, we're going to have two parentheses. Okay, and there's two x's, put one x in each parenthesis. There's two 5's, put one 5 in each parenthesis. Make one of them positive and one of them negative. Okay, and what happens is because these are the same number but opposite signs, it makes that b term in the middle cancel out. So if we were to solve these, we'd have x plus 5 equals 0 and x minus 5 equals 0. So I get here, this will be x equals negative 5, because we're going to subtract that 5 over from both sides. This one we'd have to add 5 to both sides. So we get x equals positive 5. So the graph of this equation would go through where x is negative 5 and where x is positive 5. So let's try that again. In the second one, we do have a GCF here, so let's take a look at this. 4 will go into both of these terms, so we're going to factor out the 4. Put your GCF in front, and what's left over is 4 divided by 4 cancels to 1, and we're left with x squared. Negative 64 divided by 4 is going to be negative 16. Anytime you factor or take out a GCF and there's still a squared term, you got to see if it's going to go again. And I'm noticing that's a perfect square, and that's a perfect square with a minus between them. So we have the x times the x. This would be 4 times 4. So our answer here, when we use our pattern, is x minus 4 times x plus 4, and that equals 0, because we're going to solve it, and our original had the equal 0 on it. So you would set each one of these equal to 0. Each factor. So 4 was one of the factors. 4 equals 0. X minus 4 equals 0. And x plus 4 equals 0. Well, 4 cannot equal 0. So we're just going to ignore that one. We're going to cross it out. X minus 4 equals 0. For that to be true, the x would have to be a positive 4, which we would get if we added the 4 to both sides. So x equals 4. This would be a negative 4, because negative 4 plus 4 is 0. X equals negative 4. So this graph goes through where x is positive 4 and x is negative 4. That's going to help us when we're talking about these square roots. So remember, the standard form of a quadratic equation is ax squared plus bx plus c. The a term is always next to the x squared. The b term is always next to the single x. And the c is a constant. It does not have a variable. When we are able to use this method, solving by square roots, that's when there's no bx term. So that we're saying there's only two terms, this will not be there. Okay? That's a hint that we're allowed to use square roots. To solve using the square root method, you must have the two terms on opposite sides of the equal sign and then take the square root of both sides. So what that's saying is whatever's being squared needs to be on one side and everything else has to be on the other. So this is the same problem that we factored and solved here, but I'm going to show you how to solve it by square roots. So we're going to isolate what's being squared, so we're going to add the 25 to both sides. And we get x squared equals 25. So this is what it's saying. You must have the terms on opposite side of the equal side. So we did that. Then take the square root of both sides. So we're going to take the square root at both sides. The square root of x squared, the square root cancels the square, leaving x. And the square root of 25 is 5. So now let's look and compare these. This is x equals 5, but this one, when we did it up here, it was -5 and +5. When we're solving these, you do not know, did this +25 come from two -5s multiplying together, because -5 times -5 gives you +25, or did it come from two +5s? So you have to account for both options. So we're going to put this symbol in front that says +5 and -5. Now they match and they say the same answer. So let's try it again. We're going to isolate what's being squared, so we're going to add the 64 to both sides. And we have 4x squared equals 64. And we're trying to isolate what's being squared, so we're going to divide by 4. And we get x squared equals 16. Now you have what's being squared equal to a perfect square. Square root both sides. The square root cancels the squaring on the x. And you get x equals 4. But remember, just like up here, we have a +4 and -4. We didn't know really where that came from, so we're going to say it's positive and -4. And that accounts for where it's going to go through the x-axis. All right, so this says you need the positive negative sign because you're trying to find all the values that make the original statement true. Okay, so we don't know if it was -5 times -5 to give us the +25 here, or a +25 and or +5 and +5. Okay, so let's try some examples and see how we're doing. I've already isolated on these first ones, so we're just going to have to take the square root of both sides. The square root cancels the square, so we're left with n equals 7 because the square root of 49. But remember, we're going to put the plus or minus to account for both solutions. That makes the original statement true. On x squared equals 81. Square root both sides. The square root cancels the square, leaving x. The square root of 81 is 9, and it could have been +9 or -9 would have made the original statement true. Okay? Then we have where we're going to have to isolate what's being squared. We'll add 9 to both sides. So we have v squared equals 9. Take the square root of both sides. It's going to cancel the squaring, leaving just the v equals positive or -3. One last one on this side. Isolate what's being squared. And we get x squared equals 100. Square root both sides. The square root cancels the square, leaving just the x equals the square root of 100 is 10, and it's both positive or -10. Alright, so these can get a little more complicated because it's not always a perfect square on the other side. But let's take a look. So in this case, we're trying to isolate what m squared by itself. So we're going to go ahead and divide through by the -5 to get m squared alone. And that leaves me with m squared equals -50 divided by -5 is -10. Is +10, sorry. And if we take the square root of both sides, the square root cancels the square, leaving m. But 10 is not a perfect square, nor will it simplify down because that's 2 times 5. And so there's no pairs, nothing can come out. So what we're going to do is we're going to put a plus or minus to account for both options, and we're just going to leave it the square root of 10. So it's not always going to be a perfect square. More times than not, it's not. And let's try number 6 here. What's being squared is that v, so we got to move everything else away from it. So I'm going to subtract 10 from both sides. So I'm left with 9v squared equals 1. Okay, we're trying to isolate the v squared, so we're going to divide by 9 on both sides. So we have v squared equals 1 divided by 9. Alright, so now we have a fraction. Here's how we're going to look at this. We want to take the square root of both sides. What this really means for the fraction is saying the square root of 1 divided by the square root of 9. You can look at them individually, So this square takes out the square root, cancels a square, so we get v equals, well, the square root of 1 is 1, and the square root of 9 is 3, but you still have to have that plus or minus because it could have been positive or negative 1/3. Okay, let's keep trying some of these examples. They get a little more, that we're going to be able to simplify some of these too. So we're trying to get to x squared. Subtract 4 from both sides. You get 10x squared equals 180. We're trying to get x squared alone, so divide by 10. X squared equals 18. We got the squared all alone, so that means we can take the square root. This cancels the square. We're left with x equals positive or negative square root of 18. But will that simplify? So let's just take a look. 18 is 2 times 9. And 9 will break down again to 3 times 3. So we do have a pair of 3's. So we're going to take them and they're going to go right in between the plus and minus and the radical. But this 2 has no partner, so he's going to stay under the radical. So x equals positive or negative. Took out a 3 and a 2 was left behind. So you can end up with these irrational numbers. They do happen. All right, one last example. We're trying to isolate what's being squared, so move everything else away from it. So we're going to add 9 to both sides. And we're left with 2/3 x squared equals 16. Now, that is a perfect square, but I've got this fraction over here I got to get rid of before I can get into my x squared term, so I can square root it. If you want to get rid of a fraction, you can multiply by the reciprocal. What happens is if we multiplied them together, we'd end up with 6/6, which cancels to 1. So we multiplied by 3/2, so we need to multiply this side by 3/2 also. Remember, this 16 is really over a 1. So that will kind of give us an idea. So we're going to get x squared equals, now I'm going to do some simplifying here. This 2 can reduce with this, and that will become an 8. So now I just have 1's on the bottom, so I don't have to worry about them. And 8 times 3 is 24. My term being squared is all by itself. Square root it. The square root cancels the square, leaving just the x plus or minus the square root of 24, and then we got to start breaking that down. So how about, this is 4 times 6. 4 is 2 times 2, and 6 is 2 times 3. So we've rewritten those. I have a pair of 2's, which means one's going to come out and go in front. This 2 and 3 have no pair, so they're going to go back inside. So my x's are going to cross the x-axis at positive negative 2 square root 6, which is a decimal. You can put that in your calculator and find the exact spot that that's located. So to summarize, when we can use square roots is when we have no bx terms. We have an a term. This is a c term, because remember, the c term has no variable and a is always next to what's being squared. We have an a term and a c term and a term on the other side. So when I move that over, it's really a c term. Okay. When we look over here, we had 1 for a, and then that's our c term. Okay, so we never had a bx term. That is what needs to be true in order for us to use square roots. So hopefully that was helpful for you. Let me know if you have any questions. See you in class.
Yeah.